Okay, so this is your review for test 2, which is going to be your assignment for Friday, the 30th. You can begin to take the test whenever you would like this week. It is already open. Please use this review sheet while you are taking the test. You are allowed to. It's open notebook, so please utilize it. Okay, so first section of the notes is vocabulary, and just because they're important words that you need to kind of understand. The first thing here, it says degree, and degree refers to our highest exponent. So when you see the word degree, always think exponent. Exponent, guys, is that little number. So if I gave you something like 2x cubed plus 3x squared plus 5, my degree, right, of this polynomial is 3. It's the highest exponent. So we talked about names for these types of polynomials. This would be a cubic function because it has a highest exponent of 3. The next term here is standard form. Standard form is very important. Standard form refers to polynomials, so many terms written in order from highest to lowest. And it only refers to the exponent. So if you look back up at the purple polynomial above that I wrote, it is in standard form. Your highest exponent is 3 and it's first. Then you have your 2 and then you have nothing. So this is written in standard form because it's highest to lowest. A lot of times questions will tell you to put your answer in standard form, so you have to understand what standard form is. Once you're put in standard form, you can identify what we call the leading coefficient. I think of this as like our leader. So it's the number in front of your highest power or the number in front when your polynomial's in standard form. So let's just say I wrote or had something like negative 3x to the fourth minus 5x squared plus 7, right? So this is written in standard form because we're going from the highest exponent of 4 down to the second and then down to nothing. So we are written in standard form. So now when you're identifying your leading coefficient or your leader, you're just looking for the number in front. So in this case, my leading coefficient, LC, would be negative 3. So it does not matter the numbers in the front. All you're looking to make sure is that your exponents go from highest to lowest, and then you're picking out that number in the very front. Okay, the fourth definition here is addition property of equality, which just means that you're adding a number or term to both sides of an equal sign to keep it equal. So something like this would look like x minus 3 is equal to 8. And then what you would see is that in the next line, they would just give you x equals 11. And they would say what property justifies how they got from the first step to the second step. And you're going to have to kind of figure it out. Well, what's different? Okay, so what's different is the fact that this negative or minus 3 is no longer there. And then the 11 changed from 8 to 11. So then you have to think, how could that happen? Well, it could happen if I added 3 to both sides of this equation. So that's the addition property to keep the equation equal. Okay, because this would cancel, leaving you with x, which is what's here, and 8 plus 3 is 11. So that's the addition property of equality. The distributive property talks about multiplying a term on the outside of a parentheses to all the terms on the inside. So again, something would look like this. So I would give you something that looks like this, and then I would give you a second step that looks like this. And I'd say, how did we get from the first step, the given, to the second step? So you would again have to look at the fact that we started with parentheses and then we no longer have them, right? So what we did to get rid of them is we took the 2 and we multiplied them into the parentheses. We distributed them. So 2 times x is 2x and 2 times 3 is 6, and we distributed to get rid of the parentheses. The last or the next property is the commutative property. This is our change order I remember it by CO, change order. So an example of this, I'll give you a couple just so that we could start off basic. If I just did A plus B is equal to B plus A, that's a very basic example of the commutative property. We are changing our order of the A and the B. Another way you might see it is if I went 2 times A plus B is now equal to A plus B, and the 2 is now moved to the back of the parenthesis. Same thing though. What happened is the order of my terms changed. The 2 was in the front, now it's behind, right? So it can be multiple ways written, the commutative property. You just have to be able to identify if I changed order CO, then it's commutative. Okay, on this test, you're also going to see rational and irrational numbers. So rational numbers, remember, they're those nice numbers, I like to say. They can be written as fractions. Every rational number can be written as fractions. So when we're trying to give examples, the first one is terminating decimal. That just means that it's an ending decimal. So 2.45, 1.3857, it still stops, so it's still rational. These are all examples of terminating or ending decimals, okay, which then therefore they are rational. So sometimes you will have to put terms into your calculator to determine if you're getting this terminating decimal. But again, if you get a decimal that stops, then it's rational. Repeating decimals are also rational, so something like 1.3333, and then you would see like a ... That's rational because it's the same number over and over. Another way to write a repeating decimal is just 2.5, and you put a bar over the 5, and that tells us that that 5 is repeating itself. Okay, the next one or way that something can be rational is a fraction. That's the definition by fraction. So 2/3 is rational. -1/8 is rational, right? They're all rational because they're written as fractions with 2 integers. And then the last one here is a perfect square. So the square root of 16 is rational. And again, check it. If you weren't sure if something was rational, you can always do second x squared, put it in the calculator, and you would get 4, which is a whole number, which is therefore rational. Okay, then we have our irrational numbers, and it's just a number that we cannot express as a fraction. And I call these crazy numbers. So if you get numbers that are crazy, meaning they go on forever, there's no repetition. So something like 2.4358, and then ... to show that it's going on. Okay, that's a non-repeating and non-terminating decimal. So therefore it's irrational, it's crazy. There's no pattern here. There's nothing I can say. I know what's going to come next, right? It's crazy. The second part here is non-perfect squares. So like if I did the square root of 8, and I just want to show you this in the calculator, second x squared, and then I put in my 8, I get 2.828427125. So this is a decimal, right? It kind of fills up my whole calculator screen in terms of it's maxed out the spacing. So it appears like in your calculator this decimal stops because you don't see the ... But because your calculator has the capability to only show 10 digits, this technically maxes out the screen. Therefore, it's going to keep going on, and it is irrational. So just keep that in mind, that sometimes we think that the decimal's stopping because the calculator can't show us anymore, but it is not stopping. Okay, so those are all your terms. Now we get into the practice problems. These mimic some of the questions that you're going to see on the test. So please, again, have them handy. The numbers are going to be different, but the methods will be the same. So if you write stuff down, it will definitely help. So number 1 says, which polynomial has a leading coefficient of 5? So that's key. And a degree of 2. So what do these two things mean? So a leading coefficient of 5 means that the number in front of the highest exponent is 5, right? That's what that means. By definition, that's what that means. When you see degree of 2, that just means that the highest exponent is going to be 2. So when you're looking at your choices here, start eliminating things that don't have what we just said. So when we look at A, you can see that our highest exponent is 5. We want our highest exponent to be 2, so this cannot be our answer. B, okay, our highest exponent here is a 3. Okay, so that does not work. And then C is the only one that has a highest exponent of 2, right? So if we wrote this in standard form, highest to lowest, we'd have a negative 5x squared plus x, because that's the next highest exponent, and then plus 5. So this satisfies the highest degree or highest exponent being 2, but the leading coefficient of 5, and here's where there's a mistake, it should be negative 5, right? Because our leading coefficient is negative 5. So I made a mistake on the review sheet. This should say negative 5, and then the choice would be C. Okay, it has a degree of 2. It has a leading coefficient of negative 5. Okay, here, when solving the equation x squared plus 6 equals 7x minus 8, Sam wrote x squared plus 14 equals 7x. What property did she use? So when we do these, you're comparing what's different or analyzing what's different. So when I'm looking at the given equation, right, what is no longer there in the second part? Well, it looks like my 6 is no longer a 6. It changed to a 14. And then it looks like I had a negative 8, and now it's gone, right? So now we're going to think about how can I get rid of a negative 8 or a minus 8? And the only way to do that would be to add 8 to both sides of our equal sign. And in doing that, these will cancel, and 6 plus 8 would give me that 14 that they got. This, by definition, we did this in the vocabulary section, is the addition property of equality. We're adding to keep the equation equal. Okay, the next one talks about writing the polynomial in standard form. Well, again, standard form, by definition, we did this in the vocabulary, is highest exponent to lowest exponent. So when we write this out, we're only looking at our exponents, which are those small numbers. So we're going to only look at the 5, the 1, the 3, and the 7. That's it. The highest number in the exponents is the 7, so we're going to put that term first. Then we have the 5, so plus 6x to the 5th. Then we have the 3, so minus 3x cubed. And then we have the plus 8x. We are now written in standard form. We have 7, 5, 3, 1. We're from highest to lowest. And we are all set. Okay, number 4 says simplify this expression. So it says you're doing 9x squared minus 9x plus 1 is subtracted from 12x squared plus 4x minus 5. So I circled the word from because from is one of those key words that you have to remember is a switch word. So what you first would have to do is switch these two giant parentheses here. So 12x squared plus 4x minus 5 now goes first. And we are then subtracting 9x squared minus 9x plus 1. Okay, now we have to do what we call keep, change, change. So we're going to keep this the same. We're going to change the subtraction to addition. And then we're going to change all 3 signs in this second parenthesis. So negative 9x squared, positive 9x, and negative 1. Okay, the first parenthesis remains the same. So we're just going to bring that down. And then what you're going to do is now combine like terms. So like terms have to have the same variable and exponent. So 12x squared plus a negative 9x squared would give us 3x squared. 4x plus 9x would be 13x. And then negative 5 and negative 1 would be negative 6. So your answer would be these three terms down here. Okay, the next one is very similar to number 4, except it's telling you in words what to do. So this one says that they want us to take the sum, which just means add, of P of x and Q of x. So they're telling us what P of x is, and they're telling us what Q of x is. So we're just going to add these two things together. So I'm going to keep P of x together by putting it in parentheses and keep Q of x together by putting it in parentheses. So P of x is 3x squared plus 5x minus 8. And Q of x is negative 6x squared minus 4x plus 5. Okay, then you're just combining like terms. You don't have to do keep change for this one because there's no subtraction. You're just adding these together. So 3x squared plus a negative 6x squared is negative 3x squared. 5x and a negative 4x would just be 1x. And then negative 8 and 5 would be negative 3. And that would be your answer. Okay, so state the coefficient for the term whose variable is y squared in the expression. So coefficient just means the number in front of. So we are going to look for y squared first. That's going to be our goal first. So y squared, when we're looking, is this term here. And all you're identifying or picking out of that is the number in front of y squared. So in this case, it's a positive 4. So that would be your coefficient, positive 4. Okay, so number 7, we're translating the statement into an expression. So this was, I believe, lesson 5. So triple a number squared plus 1. So triple means times 3. A number, we don't know what number, so let's use x. Squared. Now squared means that I'm going to take this whole 3x and I'm literally going to square it. And then plus 1. So just keep in mind that multiplication, that 3 times, we don't have to write with the dot in the middle. We could just rewrite this as 3x squared plus 1. Number 8, same thing, same directions. So it says 7 less than is a switch word. The square, so again, we're going to be doing that square of the product, which means multiply. So this is an exponent of 2, of 12 and a number. So when you see the word product, you have to move it in between your two where the word and is, and then it erases from here. And then you have to remember this squared also is we're squaring this product. So this would be 2x.
Mrs. Meadows, please call extension 7576.
So the 12x would go in parentheses, and then the squared would go on the outside. So when we rewrite this and we do our actual switch, it would be 12x squared minus 7. Okay, and then number 9, the last one here is just a word problem, and we're going to translate and write an expression it wants us to do. So to watch a varsity basketball game, spectators must buy a ticket at the door. The cost of an adult ticket is $4, so I see numbers, I'm going to kind of box that off. Adult ticket is $4, and a student ticket is $2.50. If the number of adult tickets sold is A, and student tickets is S, write an expression to represent the amount of money collected at the door. So when you think about the amount of money collected at the door, you're going to have your adult tickets plus your student tickets. That'll give us the total. So adult tickets are $4, and we know that A is what they're representing adult tickets by. So for adults, it would be $4 times that A. We're going to add now student tickets. Student tickets are $250, and they told us to use S for student tickets. This expression right here is all they're looking for. They just want you to write something out that represents the total. Okay, so that's the whole review sheet. Please make sure you use this while taking the test. Rewatch the video for extra practice. It will 100% help you, and have it next to you while taking the exam.